Alright, we're here at gotomath.com and we're doing numerical integration. We're down here, we're going to be looking at 3.1. It says use the trapezoidal rule for approximating. We're going to let n equal 4 here. Okay, let's just click on it and see what happens. Use the trapezoidal rule for approximating the definite integral n equal to 4. And I'll read what it says out here. It says round to 4 decimal places if needed. Alright, so let's go ahead and write this down. 0 to 5 pi thirds. 0 to 5 pi thirds of sine x. 0 to 5 pi thirds sine x dx. So we're going to get an approximation to this guy. Now we're going to be using the trapezoidal rule. Alright, like it said. And do we remember what that is? Now I'm not going to go through all the details like I did in the previous on how to do the trapezoid rule. Right. First off, we'll go ahead and state this, that f of x is our sine x, and we're on the interval between 0 and 5 pi thirds, and it said that the number of subintervals is going to be 4. So remember, in order to use the trapezoid rule, f must be continuous on this interval. And for approximating the trapezoid rule, all right, we are going to, I'll just go ahead and state this. Remember, it's b minus a, so in this particular case, it'll be 5 pi thirds minus 0 over 2 times 4. And this stuff right here inside is f of x naught plus 2 times f of x1 plus 2 times f of x2 plus 2 times f of x3. And then the last one, of course, has a coefficient. We're not going to be able to get it in here. It doesn't look like. F of x4 has a coefficient of 1. Okay, so unfortunately, we weren't able to get all that in there. All right. Now, let's talk about something here real quick. Delta x is equal to, now this is the right endpoint, is what it's called, so what we're going to be doing. But delta x is 5 pi thirds minus 0 over 4. Right, so this ends up being 5 pi, and take that down into the denominator, and that looks like that's going to be 12. Okay, so this is going to end up being our delta x, and our x of I, remember, is a plus delta x times I. Okay. All right. So the first thing we're going to go ahead and do is let's just get x of 0. Okay. That would be this guy right here. Let's go ahead and do that. And so that's going to end up being, we're starting at a, which happens to be 0, plus, and then our delta x, which is 5 pi 12 times 0, so it looks like x of 0, we're starting at 0. And then we have x of 1, 0, plus 5 pi 12 times 1 is 5 pi 12, so that's easy enough, right? And then x of 2 is equal to 0 plus 5 pi 12 times 2, and that'll actually reduce down to 2 goes into 12 6 times, so 5 pi sixth. I guess what we're going to need to do is scroll up the screen here. So now we have x of 3, that's equal to 0 plus 5 pi 12ths times 3, and that'll reduce down to 5 pi fourths. And then of course this last one here, it better be equal to our endpoint. 0 plus 5 pi 12ths times 4, which is 5 pi thirds, and that's what we started with. Alright, so these two here had better be our A, and that better be our B, or we probably did something wrong. Right? Let's try to utilize this area. And so what we're going to do now is, let's see if I can show this. Okay, so f of x naught, that'll be the first thing that we look at. F of x naught is equal to, and f of x naught, so we take x naught, which is this guy right here, and plug it into our function, which happens to be sine x, so this would be sine of 0, right, because our 0 goes into the function there. And then the next one is 2 times f of x1, so this becomes 2 times sine of x of 1 is 5 pi 12ths, 5 pi 12ths, and then we have 2 times f of x 2, 2 times sine, and x of 2 is 5 pi 6th, 5 pi 6, we could actually get an exact value to that. 2 times f of x 3, so 2 times sine, and that's going to be 5 pi fourths, 5 pi fourths, and then we got 2, no, we're done. X of 4, because this has a coefficient of 1. So f of x 4 is equal to sine of 5 pi thirds, as you can see here, 5 pi thirds. Alright. Okay, so I'm going to go ahead and write this out here. We went from 0 to 5 pi thirds of sine x dx, and this is going to be approximately, so it was b minus a, and over 2n, right? B minus a over 2n. Let's just go ahead and write all that out. 5 pi thirds minus 0 over 2 times 4. Alright. And so now what we're going to do is just go ahead and sum all of these guys up. So you would say sine of 0 plus 2 times the sine of 5 pi 12ths plus 2 times the sine of 5 pi 6 plus 2 times the sine of 5 pi fourths, and of course I'd run out of room, plus sine of 5 pi thirds. We'll close that off. So we just had to bring this down. Now what I'm going to do, now you can get the exact value actually on this stuff, but since we're approximating to 4 decimal places, you know, what's the point? We'll just plug all this stuff in and see what we end up with. How's that? So I'm going to go ahead and get this number here first. Alright. Okay, so hopefully, and I'm going to use a calculator to do this, I'll let you guys figure out. Of course, sine of 0, I think everybody knows what sine of 0 is, right? Surely you do. Plus 2 times the sine of 5 pi 12ths plus 2 times the sine of 5 pi 6 plus 2 times the sine of 5 pi fourths plus the sine of 5 pi thirds. Alright, got all that. Now I'm going to go ahead and just write this out here. I got 0.65161268. I'm going out this far because remember we're going to round to 4 decimal places, but anyway, there it is. So this up here was going to end up being 5 pi 8. No, let's see, 8 times 3 is 24. 5 pi over 24 times 5 pi, let's see, divided by, let's see, 8 and 3 is 24, right? I hope that's right. I'll have to do this problem again. Anyway, I'm getting approximately, after the smoke has cleared, 0.4265 if we're going to round to 4 decimal places, right? 0.4265, yeah. And there it is. Okay. So actually, let's just, for the heck of it, let's look at what the exact value, or an approximation to, I'm going to actually calculate the exact value here real quick, just on the calculator. Well, I don't know if it'll be exact, but closest value anyway. Well, it's 1/2. It's 1/2, 0.5, so that's close to 0.5, I guess. Anyway, so there's the steps of using back to the trapezoid rule. You can go back to these problems here, or actually this section here, if you want to see the details on the trapezoid rule. Alright. Okay, 12 minutes. Wow. Come on over to gotomath.com. Check it out. See you there.